In this video, we're going to look at the different type of linear inequality notes. So let's start by looking at our example. Here's our rules to graph linear inequalities. Step 1. Graph the inequality as if it was a regular slope-intercept equation. Step 2. Decide whether the line is solid or dashed. We use solid lines if we have greater than or equal to or less than or equal to. Notice it's got the equal to part. We use dashed lines if we have strictly greater than or strictly less than. Step 3. We can then pick a point not on a line. 0, 0 is the easiest math if it's not on a line. Otherwise, you'd have to pick a different point. You can really pick any point. And you're either going to shade above the line or below the line. We're going to check that point by plugging in the equality. If it's true, we shade that side of the line that has that point. If it's false, we would shade the other side of the line that has that point. Every point in the feasible region is a solution to the equality. So this is the part that's true. Feasible region is cut off by the boundary line. The only way to represent the infinite number of solutions to these problems is to graph it. So what does that all mean? Well, in our first example here, we have y is greater than or equal to 1/3 x minus 5. So step 1, we're going to graph the equation y equals 1/3 x minus 5. So again, put a point at -5 for our y-intercept. From there, we go up 1 to the right 3, put a point. Up 1 to the right 3, put a point, etc. Because it's greater than or equal to, that says up there we should use a solid line that's greater than or equal to. So we're going to do a solid line. So this is a solid line, not a dashed line. Remember, a solid line means that every point on that line is also part of the solution. Because this is our boundary cutoff, it's either going to be above the line or below the line. One of the things we can do then is pick a point not on the line. For example, I picked 0, 0. We plug in the point 0, 0. 0 is x, 0 is y. So 0 is supposed to be greater than or equal to 1/3 times 0 minus 5. Right? We plugged in 0 for the x, plugged in 0 for the y, and that gives me 0 is greater than or equal to -5. Is that true? Yeah, that's true. Because that's true then, I'm going to shade above this line. So every point above this line is part of the answer that works. So you could pick any point above this line. For example, if I plug in 6, 3, 6 for the x, 3 for the y, 6 divided by 3 would be 2, minus 5 would be -3. That is indeed, 3 is indeed greater than or equal to the -3 if I plug that in. So what this says is here's all of the possible answers that make this inequality true. Again, the only way to really represent this infinite set of answers is to graph it. If you try any point below this line, like 0 and -9, you would find that that would not work, right? 0 for x would give me 0 minus 5 would be -5. Is -9 greater than or equal to -5? No. So turns out that this line is our boundary line, cuts it off. And you need to decide, is my solution then above the line or below the line? And again, you figure that out by picking a point not on the line and just plugging in and see, does it make the inequality true? If it does, shade that side as true. If it's false, it means the other side is true, and then you just shade that other side. Now let's take a look at number 1. For number 1, we have y greater than or equal to -3/2x plus 6. Why don't you take a moment and try to graph the line, decide is it solid or dashed. I'd plug in maybe 0, 0. Again, you can pick any point that's not on the line, and see what would this graph look like. Why don't you take some time and try to do that. Otherwise, that's going to look like this. For our first part, what are we going to graph? Well, we're going to graph the equation y equals -3/2x plus 6. So I'm going to graph that line. Before I graph, is that line going to be solid or dashed? Again, I'm looking at the inequality. Does it have that line underneath? If it does, then we're going to say that it is a solid line. So we're graphing the point at +6. From there, going down 3 to the right 2, put a point, down 3 to the right 2, put a point. etc. Now we're going to plug in a point not on that line. Again, I can pick any point as long as it's not on this line, because you're trying to find which side is it going to be shaded on. So we don't want to pick a point on that line. As I said, 0, 0 is the easiest, so I'm going to plug in a point 0, 0. 0 for the x, 0 for the y, and then see, does it make that inequality true? If you haven't done so already, try that. Otherwise, that'll look like this. We get 0 is supposed to be greater than or equal to negative 3 over 2 times 0 plus 6. Well, that gives me 0 is supposed to be greater than or equal to 6, because negative 3 divided by 2 times 0 is 0. So we're left with just 6 on the right. Is that true or is that false? Well, that would be false, which means I'm going to have a graph that looks like this. Because this side's false, this other side's the true side. That's my feasible region. So my answer is above this solid line at y equals negative 3 over 2x plus 6. So that's how you graph this inequality. We graph that line just like normal. We decide is it solid or dashed. It's solid because it's got the line underneath. And then we pick a point not on the line. Again, if this side's false, it means this side's true, and we would shade this side. Now let's take a look at number 2. We have y less than or equal to 4 over 3x minus 6. Again, if you haven't tried it, I would try it, see if you can do it. Otherwise, we start with step 1, and we're going to graph. What are we going to graph? What equation? We're graphing y equals 4 over 3x minus 6. Again, is that going to be a solid or dashed line? Again, we look at my inequality. If it's got that line underneath, it means it includes that line, the points on that line, so that would be solid line. And so we'll graph that, and then we see that we have a graph that looks like this with a solid line. Remember, my y-intercept's at negative 6. From there, I went up 1, 2, 3, 4 to the right, 1, 2, 3. That's at 4 over 3, right? Rise over run. Up 4 to the right 3, up 4 to the right 3. And made it a solid line because it's got the equal to part. Now what I need to do is figure out which side to shade. It'll be the left side or it will be the right side. Again, I can pick a point not on the line. I think 0, 0 is by far the easiest point to try to plug in and do the math for. But again, any point not on the line works. Take a moment if you haven't done so already and try that. And that's going to look like this. We plugged in 0 for the y, we plugged in 0 for the x, and that gives me 0 less than or equal to 4 over 3 times 0 minus 6, and we get 0 is supposed to be less than or equal to negative 6. Is that true or false? We see that that is false. So that means that this side at the 0, 0 is false, so it makes the other side true. So we're going to have a graph that looks like this. Notice that this time we shaded below the line. Again, we're shaded the side that's true, not false. Now let's take a look at number 3. For number 3 of y greater than 2x minus 5. Again, if you haven't tried this, try it now. You probably should be able to do it. Otherwise, that'll look like this. We'll start by graphing what equation? Y equals 2x minus 5. And this one, is it going to be a solid or dashed line? Notice this time it's going to be a dashed line. So let's graph that. Note that a dashed line also means open circles. So we start with an open circle at negative 5 on the y-axis, as that's my y-intercept. From there we're doing our slope. Our slope is 2. Remember, that means we're going up 2 and to the right 1, and up 2 to the right 1, etc. And then we have dashed lines. Notice that my line is not connected, so that's dashed. So they have this break in between different parts to show that it's not connected. So solid line means it would be totally connected. Dashed line means that it's got breaks in between. And again, what that means is none of these points on this line are an answer to this inequality, because it would make it equal to where we don't want equal to. Now again, we're going to pick a point not on the line. Can I use 0, 0? Yep, I could. If you haven't done so already, why don't you try that? Again, if you'd rather try a different point, you can. Either way, you should still get the same side to shade on. If I use 0, 0, it's going to look like this. Again, I plugged in 0 for the y, 0 for the x, and that gives me 0 is supposed to be greater than negative 5. Is that true or is that false? Is 0 bigger than negative 5? Yes, that's true. And because that's true, we would shade the side then of the 0, 0, giving us a graph that looks like this. And so what you typically see is drawing some lines perpendicular to your boundary line, and that just shows that we're shading this side. So instead of like filling it in completely, that's typically what you see if you do it by hand. Now let's take a look at number 4. For number 4, we have y less than negative 1 over 5x plus 4. Again, if you haven't done this already, try graphing this. See if you can do this now that you've seen the other two. Otherwise, that's going to look like this. We already know we're going to graph the equation negative 1 over 5x plus 4 is equal to y. Is it going to be solid or dashed? You see, because it's strictly less than, it's going to be dashed. So let's graph that. Remember, dashed means that we're going to have open circles and dashed lines or dotted lines. So I put a point at positive 4, again, open circle. I went down 1 to the right 5, down 1 to the right 5. Remember, that's what my slope is. Rise over run is down 1 to the right 5. And now we need to plug in a point not on that line. If you haven't done so already, try a point not on that line and see which side should you shade. You might already have an idea what that might be, but just verify it. I, of course, decided to go with 0, 0 and plug that in place of y and in place of x to give me 0 less than negative 1 over 5 multiplied by 0 plus 4. That gives us 0 is supposed to be less than 4. Is that true or is that false? We see that that is true, thus we're going to shade below the line on the true side. And it's a good thing to remember as well that this goes well beyond the graph that we see, all the way out to negative 100 comma 3 is definitely going to have a shade, right? Because it's going to be below the line. So it's well outside just the graph that we see as well. Remember, these arrows mean it continues on forever. Take a moment and look at our graphs. What do you notice? When did I have solid lines? When did I have dashed lines? When did I shade above the line? When did I shade below the line? And what kind of pattern do you notice? And one of the things I'm hoping that you realize is for greater than, we shaded above the line. For less than, we shaded below the lines. And notice that I was solid line when it had the equal to part. Dash line when it was strictly less than or greater than. And if you start to notice this, you can get away without having to check a point not on the line. If you realize that, hey, anytime it's greater than, it's going to be above the line. If it's still confusing, you can always plug in a point not on the line. But that's one of the things I want us to start realizing. So one of the other things to note is we often graph the true side, which is called the feasible region. Sometimes, though, it's easier for us to graph the false side, so that's the non-feasible region, because we want to find the part that's left over. That's when more useful when we get into systems of inequalities. We sometimes graph the non-feasible region so that we can tell which side is left over instead of the overlap. But most of the time, we'll be graphing the feasible region. Last two major ideas is, on the previous one, we were already in slope-intercept form, but now we're in standard form. So let's solve our linear inequalities into slope-intercept form so that we can graph this. Take a moment and try to solve A and B. And let's start with A. For A, we have 2x minus 3y is greater than 15. Take a moment, try to solve that. Otherwise, that's going to look like this. We subtracted 2x from both sides to give me negative 3y greater than negative 2x plus 15. Or you could say 15 minus 2x. From there, I divided by the number in front of the y, so I divided both sides by negative 3. Now that negative 3 gets divided by both parts, so I get y, I have 2/3 x minus 5, but notice that I flipped the inequality sign. I flipped the inequality sign because I divided by a negative. So now I can graph y less than 2/3 x minus 5. Take a moment and try to do that. Take a look at the first page if you need help on remembering, is it a solid or dashed line? Am I going to shade above or below the line? See if you can figure that out. Otherwise, that's going to look like this. We start by graphing the equation y equals 2/3 x minus 5. So again, y-intercept to negative 5, up 2 to the right 3, up 2 to the right 3, because it's a positive slope, means I go up and to the right. And because it's strictly less than, it's going to be a dashed line. And because it's y less than this, is that going to be above the line or below the line? That will be below the line. This is like number 4 on our first page example. Now let's look at part B. I have 6x plus 3y is greater than negative 24. Again, take a moment, try to solve that for y, and then try to graph it. Otherwise, let's start with solving. That's going to look like this. We start by subtracting 6x from both sides. We then divide it by 3, and we end up with y greater than negative 2x minus 8. We didn't flip the inequality sign because I didn't divide by negative, I divided by a positive 3. Even though these are negative, the negative 6x and then negative 24, doesn't matter. The number that's in front of your letter, when you get down to number, letter, and then the rest of it, that's the part that matters. So since this is a positive 3 in front of the y, I don't flip the inequality sign. So should have got y greater than negative 2x minus 8. Take a moment and see if you can graph that then. Otherwise, that'll look like this. We have an open circle at negative 8. From there, we went down 2 to the right 1, put a point. Similarly, I had to go up 2, back 1 to get my other points. Now it's a dashed line because strictly greater than has to be open circles with dashed lines. And that means that nothing on this dashed line or open circles is part of the solution. Since it's y greater than negative 2x minus 8, we ask ourselves, is that shading above the line to the right or below the line to the left? Again, refer back to that first page to see what that would look like. And we see that that's going to be, we're going to shade above the line, so that's to the right. Just ask yourself, which side is greater? Right, this is bigger than the negative side, so that's why I'm shading on the right, above the line. And this is how we graph inequalities. Sometimes we are in slope-intercept, like on page 1. Otherwise, we're in standard form when we might have to put in the slope-intercept form to graph it.